Okay, in this video we're going to be talking about Euler paths and Euler circuits. It's in section 4.4 in your book, just in case you want to follow along and get any additional information. So let's go ahead and get started. A Euler circuit is a path that uses each edge of a graph exactly once and ends at the starting vertex. Okay. Now, a couple of things I want you to take note of before we move forward, and that is this. Each vertex must have an even degree. Now, this may not make any sense to you, so let me go ahead and draw something, and let's see if that can possibly shed some light. Okay, so I drew a very simple graph right to the right of the screen, and what we're going to do is we are actually going to figure out whether or not this has a Euler circuit, and I'm going to pay attention to what I highlighted in green here. It says each vertex must have an even degree. Well, if you remember, a degree is defined as how many edges are actually touching a vertex. So if I was to look at this edge right here, or I'm sorry, this vertex right there, how many edges are touching it? Well, there'll be two. What about this down here? It'd be two as well. What about this? Two as well. And this is two. So they're all two. So notice that every vertex has an even degree, which is exactly what Euler states. Now, what you're going to do is basically you're going to recreate this graph without picking up your pencil or tracing over any additional edge. So if I was to start here, notice how I am drawing over the edges, recreating my graph, and I'm able to get back to my starting point, which was right here. This is an example of a Euler circuit. Let's try another example. Okay, here's my other example now on the left of the screen. Once again, I'm going to figure out whether or not this has a Euler circuit by counting all or checking each vertex to see if they have an even degree. Well, in this case, this has a 2. This one has a 2. Remember, I'm counting which degree or each vertex has by figuring out how many edges are touching the degree. And I'm figuring out that, oh, all of them have an even number. So since all of them have an even number of degrees, that means it's going to be a Euler circuit. Now the next part I'm going to have to do is actually creating the circuit, meaning can I recreate this graph? Now what I'm going to do is I'm just going to choose at random what vertex to start with. So I'm going to start at this 2 right here. Okay, so I'm going to start at this 2, and I'm just going to basically draw the way I want to as long as I stay on an edge and not repeat. Now notice that I'm going back to the same edge right here. That's okay. You can go back to the same vertex as long as you do not come back to each edge more than once. And as you can see, I just created it and it is a Euler circuit. I was able to start and finish from my starting vertex, and so it's going to be a Euler circuit. Let's try one more. Okay, here's our next one that we're going to do here. So let's go ahead and count all of the degrees. Well, this one has 2. Oop, let me, there you go. This one has 2. This one also has 2. But if you notice, this one now has 3. And this one also has 3. See, because of the fact that this right here, or this one right here, depending on which one you want to work on, has an odd number, then you already know that this is not going to be a circuit. Okay? So if the question was, can you create a Euler circuit? The answer would be no. Now, that's how you figure out if you're just looking at the degrees. But if you actually wanted to draw it out, just to visualize why we cannot recreate it, I'm just going to start at this 2 here. And I'm just going to try to recreate this problem. And, oh, I'm stuck. I can't get back to my starting point um, unless I retrace an edge. Let's try it again. So let me just start right here. It seems to be easier. Okay. Well, I was able to recreate the graph, but I was not able to get back to my starting point. So if that's ever the case to where if you have a starting point that is, let's just say, I can't remember which vertex it was. Let's just say this vertex here. And if you notice, I ended here. So I started and ended at different vertices. Then what we have here is what is called a Euler path, which is right there. A Euler path is a graph that has exactly 2 odd degree vertices, but the definition is a path that starts and ends with different vertices. So this was an example of a path. Okay, now let's try another one and let's determine whether or not it's going to be a Euler path or a Euler circuit or maybe neither at all or none at all. Okay, here's the next one I'm going to do here. So let me just go ahead and count all the degrees of each vertex. So this right thing, this is 2, this is 2, this is 2 as well. Remember how many edges are touching it. This is 2 as well. But oh, look at this one. This has 3. So right then and there, we already know it's going to disqualify us for it, or disqualify the fact that it's going to be a circuit. So it's not going to be a circuit. That means I will not be able to start and finish from at the same vertex. But it has one odd degree, and then, oh, here's another one. So it has exactly 2 odd degree vertices, which is the definition of a Euler path. So I already know that this is going to be a path. The next thing I need to figure out is whether or not I can actually draw it. Now, I kind of gave myself a challenging one, so let's see if I can try this, okay? I already know it's going to be a path, I just need to find it, all right? So I'm just going to start at this vertex here, and let's see if I can retrace this thing. Let's see. Oop, I think I just messed up. All right, I can't do that. Let me try one more time. If not, I'm just going to pause the video and do it myself. Just try to do it all while the camera's paused. And nope, but I think I figured out how to do it. So let's try it one more time. All right, let me just start here. Draw. Oop, I think I got it. All right, there it is. So I don't know if you remembered, but I ended up starting at this vertex, but I finished at that vertex. So that is a Euler path and Euler circuit. So let's just try one more because I got some time and you guys have nothing else going on right now. So let me recreate one more to see if it's going to be a Euler path or circuit or neither. Okay, this is the last one we're going to do until we call it a wrap on the video. So let's see, this has a 3 here, this has a 3 here. Degrees wise, that is 1, 2, 3, 4, 5. This is 5. This right here is 3. Feel free to pause the video whenever you want to try yourself. And then 2, and then 2. All right, so let's see what we have here. We have, this is an odd vertex, so we already know it's not going to be a circuit. This right here is also an odd vertex. So, okay, as long as we don't have any other odd vertices, we're good to go. Whoa, there it is. That's our third vertex. That's as far as we have to go. We're not going to go any further. So we already know that's not going to be a path, a circuit, or anything. So we're going to call this a big no, as in no, it's not either one of those two. You cannot do it. And so there you have it. If you have any questions, please let me know the next time you see me. Thank you.